database. We talk about database, there are multiple definitions out there, but a very simple definition is a structured collection of data that is stored and accessed electronically. Another definition for database as a database are used to manage and organize large amounts of information efficiently. And some people will just say they allow users to store, retrieve, update, and delete data in a systematic way. Whichever one, they are all correct. The main thing about database is that it stores data, and you can retrieve the data and you can update the data that is stored in the database. There are multiple types of database out there, but these are categorized into just two. We have the relational database and the non-relational database. And under each of these databases, there are multiple different types of database, but these are just like the category. So when we talk about relational database, a relational database stores data in one or multiple related tables. They can use one table, or they can use multiple tables to store data. And they organize this data in rows and columns. Whenever you want to search for data that is stored in a relational database, we use what is called a structured query language, which is called SQL, structured query language. And this is an example of a database that is stored in a table, or an example of a data in a table. You're going to have the ID, the username, and the state. So for example, these two users, we have the first user, that is Mike Fisher, which stays in Missouri, and we have Sarah Long, which is from Florida. This is just the information, like their profile or their basic information. If these users, maybe you want to check, or we are keeping how much their net worth is, then you can have another table that is going to show you the net worth of the users. So now we are storing these people information in two different tables, and these two tables are related. So how do you know they are related? If you look at the second table, which is talking about the net worth, the users' names are not there. So how do you know which user earns or what 200,000 and which user earns 100,000? Well, there is a relation in this table. If you look at column 2, the second column, we have the FID. The column 1 have ID and column 3 have net worth. The FID is talking about the foreign ID. It's called the foreign ID. I'm talking about the foreign ID, and the first one, this one, or here, is a primary ID. And this one too is a primary ID. So when we talk about the primary ID, it's just like a particular item that you can use to identify a user. Here, this ID, we use it as primary ID, which identifies this user. And no two users will have exactly the same primary ID, because that is the only way we identify the user. You can, if I continue writing different users now, or different multiple username, you will get to a stage that two different people, even three different people, will share exactly, or we have exactly the same name. But the only thing that they cannot have together is their ID, because we are going to have 1, 2, and continue like that. So this ID on this table is the only way that we can identify these users. So when you want to relate them to their table, to their network, you are going to import this ID into the second table. So it is this ID here, this first one here, that is tell us the ID of the users, and that's what I differentiate them. So these are what we import into the second table. So we still are able to identify the users. So the ID here, which says ID 1, is for Mike Fisher. So that tells us this row is for Mike Fisher. And what that simply means is that when you have a primary ID that is imported into another table, in the other table, it is called foreign ID, because the foreigner, it's from another place that it was imported from, and that's why it's called a foreign ID here. So when you want to have two tables that's going to be related together, you need a foreign ID, because that is the only way we can use the table in relation to one another. And that is where we have the concept of relational database from. The second form of database is non-relational database. And here, relational database do not store data in a traditional table format. We don't use a table format to store data, unlike the relational database. But non-relational database organize data in a different format, and they have multiple formats. They organize the data, but the only thing is that they don't organize data in form of tables. So what are the examples or ways that we can organize our data in non-relational database? Well, the first one is documents. You can organize your data in form of documents. You can organize it in form of JSON, and many of them. So here is when you are querying non-relational database, we use what is called a non-structured query language, and that's why in most cases people call non-relational database NoSQL. Why they call relational database SQL database? So here is an example of a non-relational database. So I still put it in table, but if you look at this information now, it's not storing the user's data in multiple tables. We only have the same, and this table is just to differentiate the users from each other. That doesn't mean that relational database. Okay, I'm taking this statement by that non-relational database don't use table. There are times that they can use table, but they don't store data in multiple tables. If you want to, like, one user has to be in the same table. And if you look at this one here, we have one user, and all the information of the user are stored here in this cell. Unlike this non-relational database that we split the user's information in two different tables, but here it just use only one. And the second user, we have all our information too here. So AWS, because this is the cloud that we are using, in AWS provide a lot of multiple database that you can use, depend on your use case. If you want a relational database on AWS provides us what is called Amazon RDS for a relational database. Amazon RDS. Amazon RDS. So Amazon RDS is a managed relational database service that allows you to run relational database in the cloud. When we talk about managed database, let's look at what is not a managed database. If you want to create your own database, you need a server. And on the server, you have to install a database engine. Then you have your data in it. So all of this structured, you have to be the one that is responsible for it. You have to create your server. Maybe you are using EC2. You have to install the database engine. Maybe this time I want to use my SQL. Then you have to bring in your data and store your data in there. But when we talk about relational database or Amazon relational database, Amazon take this one away from you. So you don't have to create the instance. You just need to specify which engine do you want to run. Then you can just go to AWS RDS and specify this engine, and you'll have a database, and you bring in your data to it. So that is why it is called a manage, because AWS manage the EC2 for you, and anything that has to do with the security of this server, then it is AWS that is going to be handling it. And the advantages of this is that you don't have access to this. You don't have access to the server. But we're going to look at multiple. So AWS provides us, let's look at the features of this RDS. The first one is that it eliminates all tedious tasks of managing database, such as the backup, the software patching, the automatic failure detection and recovery. AWS handle all those for you because you are not the one responsible for the server that the database is running on. Then the second thing is that you can turn on backup automatically. If in database you have to back up your server or your data, so that if anything happens to the server or to your data, you can restore your data back or your database back from your backup data. And the third one is that AWS manage both the database server and the patching. I explained this earlier. You don't have to manage the server. AWS does that for you. So when you use AWS relational database, when you store your data on this database, what happens behind the scene is that AWS will store your data in multiple location availability zone. Though all of them are in the same region, but they are going to store at least 3 copies of your data in 3 different locations. So this, for them storing our data in 3 different locations, it gives us what is called highly available. So with that, you have, the relational database provide high availability. Because they have a primary server, and this server synchronized into secondary server or secondary instance. So if the primary server failed, all that just need to do, or what AWS is going to do behind the scene, is that they will start redirecting your users to the second server. So we always have what is called a primary server. Anytime you spin up an RDS, most of the time you have a primary server, and it will have a secondary server. So any data that you are saving in the primary data, it will be synchronized into the secondary data. So this way, it is very hard for us to have a failure, a failure or downtime, because any data you are saving here is synchronizing here. So if this one is faulty or the server is not running, what the system AWS will just do, you will direct your customer request directly to the second one. So when they direct your customer request to the second one, or they automatically switch this secondary into primary, and then they will launch another secondary for you. So that way, even when the primary is down, you don't have downtime, because the secondary is automatically promoted to primary, and they're going to launch another secondary. And then the primary now, the new updated primary, will also be syncing data into the secondary that they just launched. So this way, it's continuous like that, and that's why we don't have downtime, or the downtime is kind of extremely reduced. With RDS, you can use multiple or different kind of engine. It comes with different kind of engine. You can use MySQL, Oracle, Postgres, MariaDB, and Amazon Aurora. Amazon Aurora. So here are the list of the engine that you can use on my relational database. So if you have a client that is using any one of these on-prem and they want to migrate to the cloud, then you can also use or provide any of these for them to cater for their use case. But the one we're going to look at today is, or the major one that we're going to focus on, that we're going to explain, is Amazon Aurora. Every other one, they are easy, they are straightforward, but this Amazon Aurora is AWS provided engine. This is AWS home base. So with Amazon Aurora, the way it is different from your regular MySQL or PostgreSQL is that it is a fully managed engine, which means you don't have to do anything on it. AWS manages it. They created the engine. In terms of patching, they also do the patching. And it's compatible with MySQL and Postgres. So when you are creating an Amazon Aurora, you have to pick which one. Is it the one that is Aurora compatibility or Postgres compatibility? Is it the one that has Aurora, my SQL compatibility, or the one that has my Postgres compatibility. You have to pick either of the two. Then this is the good news. When you are storing your data in Aurora, it replicates that data in 6 copies. It makes 6 copies of it, and it put them in 3 different availability zones. So let's look at, if you are not using Aurora, but you are using RDS, this is what you get. Or let's start, if you create your own server, you want to manage your own server without using Amazon RDS, this is what you get. You're going to create one server, and you're going to deploy your engine on it. If you only use one server and you don't have another backup server, if the server go down, your data, your entire website will go down because your user will not be able to access it. Your application will not be able to access it. So the best case is you always have a backup server too. So now you have 2 servers, server 1 and server 2. And if you are using RDS, this is what's going to happen. Immediately you create an RDS, by default, the basic one is that you are going to have 2 servers automatically, which is called the primary and the secondary. All right. So this primary and secondary, immediately data is stored in the primary, is synced into the secondary. And if you are using MySQL, then this is what you get. And in another case, you can say you want multiple, and the IS is going to be 3. So what this 3 simply means is that you have the primary and you have 2 secondary. This is the regular MySQL. If you are not using Aurora MySQL or Postgres, this is the regular. So if you are not using Aurora, but you just want to use MySQL or Postgres, so if you say you want multi-database or multi-regional database, when I get to the console, I'll show you that. You're going to have the primary, the second, or 2 secondaries. This is the highest you can get. When data goes into this primary, it's automatically sync directly into the secondary. But this is what happens behind the scene. If the developer wants to use this database, they're going to write traffic into this primary. They can write into this primary, and they can also read from this primary. What that means is that if they connect this database to their server, their web server, what it means is that this web server can write to this and can also read from this. And the secondary, the web server too, can read from this secondary, but it cannot write to it, only read. So if you are having multiple, maybe you have a lot of users that are reading from your website, then you can direct some of the traffic into the secondary database instance. So some people will be reading from this, and some will be reading and writing from this. And they can also read from this as well, but they cannot write here. So this is another thing. If this failed, then traffic can be directed into this, and this will automatically be promoted to be primary, and they can start reading and writing from this. So they can start reading and writing from this as well. But in case of Aurora, instead of having 3, you're going to have 6. So 2 in each availability zone. So you have 2 instance server here, 2 here, and 2 here. So you can see now it provides us more availability, because once data is saved here, it will propagate or sync with every other server. So if anything happened, you have multiple copies of your server, and you can send multiple read. They can read from each one of these. So we have a lot of server to read from. And that is one of the benefits of the Aurora. It replicates 6 copies of your data in 3 different availability zones. And it can deliver up to 5 times the throughput of MySQL. So, and this is what this means. If you're using the regular MySQL, and let's say this is your database, this is MySQL, this is database with MySQL, regular one. This is your server. And this is another server, which is web server, right? Web server. But this web server is actually reading from Aurora. What's going to happen is that when a user requests data, or a web server requests data from a database that's compatible, that uses MySQL, the database can provide, like, let's say 3,000 throughput. Throughput is like, let me use an analogy to explain this. Let's say you have 2 buckets that is filled with water, and you want to take water from bucket B, you want to put it in bucket A, and you are using this small cup. This small cups, if you're using this small cup, it can go like, let's say this small cup is 2 amps. So if you start using this small cup, you can say, let's say these buckets are 20 amps. So if you are using 2 hands to take the water, it will go like 10 times. And each of the 10 times is going to have 2 hands. So the 2 hands is the throughput. That is what it can take at once. Why this 10 times that is going by? Because you have to take the first one, the second one like 10 times. This is the input. I mean IOPS, input, output, operation, IOPS. So when data is coming from the server to the database, it can take like up to 300 bytes at once. But when we are talking about Aurora, this can take like 5 times of this. That means it can take 15,000 at once. So it can take a size that is up to 15,000 bytes at once. So that is what it means, like they has a 5 times throughput. 5 times throughput for my SQL and 3 times throughput for my Postgres. And this is also a serverless, which means you don't actually manage the operating system. And when you store your data in RDS, this is what happened. If you're using RDS, the regular RDS with MySQL, you have to create an RDS and you have to pick whether you're using MySQL or other engine. So if you do not store any data here, you continue getting charged as long as you created it. But with MySQL, it's more of a serverless, meaning that it's only when you need it that it's going to spin up. It doesn't spin up and continues running automatically. So that is the relational database. For non-relational database, AWS also provide multiple service or multiple they also provide multiple service that you can use for non-relational database. And one of them is DynamoDB. And this is one of the most used service in AWS non-SQL database. I mean non-SQL service, database service. So with DynamoDB, it's also if you're using something like maybe you have a client that's currently use MongoDB. MongoDB is a database that one of the most popular non-relational database if you're using outside of AWS. So if your client is using MongoDB to store their customer data, then you can use Amazon DynamoDB for them. And it store data in form of, it actually use table too. It store data, it creates a table, it actually use table, but it store data in form of key value pair. Key value pair. Apart from my DynamoDB, there's other database service too on AWS. There are a lot of them, like 6 or 7 of them. It depends on your use case. If you have a client that's talking about, oh, they need a data warehouse. A data warehouse is just like this huge container that can store different form of data as they are coming. You can have some data from maybe from websites. You can have some data that is generated maybe from system, your servers. You can have some data maybe that is coming from a third party company. You can have some data that is generated maybe as a sort of people that are using your app. So all these data, they will come in form of raw data. And we need to store them. So we can't just go and like, okay, this is web server data. Let's go and store it in RDS. This is system data. Let's go and store it in DynamoDB. So all these data, because they are raw, we need to store all of them in the same place. And when we store them, it's like a data warehouse. So once we store them in the warehouse, we can then later be sorting them out. Oh, this one should go to this place, this one should go to this place, this one should be used for this. And majorly data stored in the warehouse is normally big data that is used for data analytics. We want to analyze where our customers are coming from. Are they all coming from Google search? Or are they coming from Facebook? Are they coming from LinkedIn? Or they are coming by with word of mouth? Maybe referral. So we want to know all of this and we can analyze the data to tell us where the customers are coming from so that we can focus more of our attention, our energy, our resources on where the majority of the customers are coming from. If Google search is only presenting or providing us 1% of the customer and our majority of our customers are actually coming from Facebook, maybe like 90% are coming from Facebook, then we want to focus our attention on this, the one that is providing the huge amount of results. So that's why we analyze data to know where the focus is coming from, where is the what is the data telling us? And data is key. It tells you everything, except if you don't know how to read it. Then another kind of data warehouse, database is Amazon DocumentDB. Amazon DocumentDB is also compatible with my MongoDB, and this one uses a JSON document. It uses JSON document. It stores the data in form of JSON. We have the Amazon Neptune, which is a graph database. And all these databases just for you to know that, okay, if a client is talking about this database, okay, we have something like that. So you just need to know what the customer is using. Then you can now say, okay, you are using DynamoDB or you're using MongoDB. This is compatible. If you're using Postgres, you can use RDS and things like that. This is just for understanding the different database on AWS. And we also have a quantum ledger database, which is more of for finances. So I'm not going to be talking much about the knowledge check because we still have a lot of things to cover. Normally that's supposed to finish today, but I've extended it with two different classes. I mean, with additional two classes, which is going to be tomorrow and Wednesday. Then we're going to have one on Saturday, which is going to be the final. So for those of you that have this, I think somebody was asking me the other day that where can they get this one? If you just go to the training.thecornelis, you can get it in the, if you log in, go to the course. This course, this is the where I put all of the courses that we're covering here. If you start learning, like you open the course, it's going to take you to the classes. So it's going to be under the first class. This first one, if you open it, you will see two. Good morning once again, everybody. So this first class, Introduction to Course and Training. If you scroll down under exercise 5, you're going to see it here. So you can download it from here. You have access to it. So for the knowledge check, you guys can review that later if you want. So I'm going